Yeah. So the next session we have is on streaming data as well from Redpanda. We have Andrew who will walk us through what they did.
I think it's showing this.
Just hit the slideshow button. Just
share
hit
is
it. There you go.
Sure. Yeah. We're not working. No. Hello? Presentation, maybe? Sure. Let's see if it works.
No, it didn't happen. 3 seconds.
Okay.
Maybe we can try it last time.
Speaker.
I think that's fusions. I believe.
Yeah.
All right. Full screen it.
Full screen it. The slideshow.
Yeah.
Yay.
Hey.
Hi, everyone. Sorry for the delay. Today I'll be talking about streaming data in Apache Iceberg with Redpanda. So first, let me introduce myself. I'm Andrew, and I'm a software engineer at Redpanda, and I've been at Redpanda for about 2.5 years, working on the core storage team, where we focus on tiered storage, compaction, storage space management, and that kind of thing. Most recently, I've been leading Redpanda's Iceberg Topics beta feature, which is the focus of today's talk. Before Redpanda, I was an engineer at Cloudera for about 5 years, working on Apache Kudu, which is another distributed storage engine in the real-time analytics space. And before that, I did an undergrad and a master's in computer science at UCLA. Now, before we begin, here's maybe the most important slide. We're giving away free merch. If you just scan this QR and fill out a form, we'll ship you a cute Redpanda shirt. Not sure how long it'll be active for, but also like a few folks from Redpanda are out here getting out beanies and stuff. If you find us, come talk to us. We're friendly. And now here's maybe the second most important slide, the TLDR of this entire presentation. If you take nothing else away but the free shirt, here is the mission statement for Redpanda Iceberg Topics. It's a zero-code approach for extending an Apache Iceberg data lake with real-time data streaming. So let's go over some agenda. First, I'll briefly introduce Redpanda. Then I'll go into a bit more detail about Redpanda Iceberg topics and how they work. Then I'll dig into some challenges we had along the way, and then some things about some things that we're working on and things to look forward to from Redpanda, and finally some reflections about the whole Apache Iceberg experience. So without further ado, let me introduce Redpanda by first introducing Apache Kafka, which I know Sujit had introduced already, but yeah. Before jumping into this slide, can I ask how many people here are either currently using Apache Kafka or have used Apache Kafka? So like a decent number of people. So Redpanda is a Kafka-compatible distributed storage engine, meaning our Redpanda clusters serve the Kafka API and store the log data in a similar way to how Kafka stores data. For those who didn't raise their hands, the key abstraction in Kafka is an append-only log. And a single log in Kafka is called a topic, which you can think of generally as the spiritual equivalent to a table in the database world. Kafka allows you to split your topic into partitions, though no partitioning here isn't necessarily value-based like it is in Iceberg. You can plug in different partitioning strategies like key-based hashing or round-robin. In Kafka, data is written to by producers and read by consumers, and the data is optionally strongly typed, and I'll go into that in a later slide. And there are Kafka clients available, written in most popular languages, but some of the common ones are Java, Python, Go, and C++. Now, Redpanda is a single binary drop-in replacement for Apache Kafka, and we generally focus on being highly performant, easier to use, and having lower total cost of ownership. And our engine is written entirely in modern C++, so C++ funny with coroutines and concepts and other fun new C++ features. We implement a thread per core architecture built in C* from the folks at SolDB to help us get better resource utilization. And in general, the Redpanda engine can be deployed in a variety of different ways, like on-prem, with your own cloud infra, as a cluster managed by Redpanda, or serverless if you don't want to think about cluster deployments. And at the risk of selling Redpanda a bit too much, here are some other things that make Redpanda Redpanda. So first, each topic partition, as you just said, is replicated with a Raft consensus group, giving us pretty strong guarantees with regards to data consistency across replicas. Our controller, which manages cluster-wide metadata, is built into the system and replicated with Raft. So this means there's no zookeeper involved and no separate service for metadata management. We have automatic data-aware partition and leader rebalancing. We have a built-in schema registry, which I'll touch in the next slide. Within the storage layer, we have tiered storage, which transparently offloads historical data to object storage. We have Kafka-compatible transaction support, audit logging, enterprise security for both authorization and authentication, and much, much more. So I'd also like to take this time to say that if any of this, or if any of the rest of the presentation sounds like something you're interested in or something you'd be interested in working on, please reach out to us because we are hiring. Now, before I jump into Iceberg, earlier I mentioned structured data, so I thought I'd explain a bit since it's important for Iceberg topics. In general, implementations of schema registries exist in the broader Apache ecosystem, and as I said, Redpandas is built into the cluster, backed by a special topic to store schemas. The schema registry is an HTTP interface that Kafka applications can talk to manage data format expectations by registering schemas with Redpanda. So when producing data, some producers may use a special wire format that includes a magic byte and schema ID, so consumers of that data know and can understand the payload structure, and so Redpanda can reject bad data. In general, Redpanda and the Kafka ecosystem support Avro, Protobuf, and JSON schemas, though Iceberg Topics only supports Avro and Protobuf for now. And with that, we have all the knowledge we need for us to talk about Redpanda Iceberg Topics. So Iceberg Topics build and automatically manage one-to-one mapping of topics to append-only Iceberg tables. As data comes in, Redpanda translates Avro or Protobuf records into Parquet and commits the translated files to the Iceberg catalog, passing along some additional metadata with each record. For this little diagram, conceptually, this allows you to still consume data as a log through the Kafka API, while also querying your data as a table with your favorite Iceberg-compatible tools. Under the hood, Redpanda infers and manages table schemas automatically with the help of the schema registry. And enabling Iceberg topics is pretty simple. You just set a single topic property in your Kafka topic called Redpanda Iceberg mode. But by default, it's disabled. But the two modes are first a key value mode where Redpanda can treat the input data as an unstructured binary log, and the resulting table contains a value binary column. And this is ideal if you want, if you can or want to process raw record bytes in your data lake. And the other mode is called value schema ID prefix, where the input records are expected to be in the special schema registry wire format. That again includes the schema ID. And in this mode, Redpanda loads the record schema and uses it to parse the payload and write it out in Parquet format. And that's really all there is to setting up Iceberg topics for a given topic. To illustrate this, this is pretty much what it looks like for a developer to set up an Iceberg topic. First, at the top, we create a topic in our desired mode. Here, we're using RDK, which is Redpanda's CLI. But you could use anything, really, to create a topic and provide the right topic property. And below is a snippet of a Kafka application that produces data with a given Avro schema. And that's really all there is to it. Redpanda takes care of the rest. And once data is written to the topic, Parquet files will begin to be generated and appended to the table. So on the Iceberg end of things, if this is on the right, this is our on the left. If this is our input address schema to a name, age, and an address, Redpanda translates the schema, adding user-defined fields as is, but also, as you can see on the right, it adds some additional metadata fields associated with each record, like the offset, the Kafka offset, timestamp, headers, partition ID. So again, not to be confused with Iceberg partitioning, with Redpanda defines for you by declaring Iceberg partitioning on the record timestamp with an hour transfer. So functionally, that's pretty much the core of Iceberg topics. And there are a few additional things that Redpanda does with Iceberg topics. So first, as new schemas come into the schema registry, and new data is produced, Redpanda will automatically update the Iceberg schema in the table, adding new columns to the table. In the current version of Redpanda, we only start adding columns, but we're actively working on the full range of Iceberg schema compatible changes like removals and type promotions. Next is table lifecycle management. I mentioned earlier that Redpanda maintains a one-to-one mapping of topics to tables, and we really need for it to. So just as Redpanda creates a table for you, you can optionally have Redpanda drop the table when dropping the topic. And in this way, managing of Iceberg topics tables can happen altogether within Redpanda. And just a note that there are a couple other more features in the pipeline, like automatic dev letter queue table management and custom Iceberg partition specs that I'll mention later. And now that you get the gist of Iceberg topics, here's how it works under the hood. At a high level, there are two major components that make up Iceberg topics: the data partition translators, which translate and upload data and are run directly on topic partition leaders, and the coordinator, which primarily interacts with the Iceberg catalog. So coordinators are co-located with leaders of partitions of a special control topic, which is a topic that stores metadata about what files are pending to upload to what pending files have been uploaded to object storage. The coordinators are in charge of creating, deleting, updating tables, and performing the Iceberg appends when there are pending files to commit. So the data path looks roughly like what you see on the right, where data enters the system through the Kafka API from your Kafka favorite producer, your favorite Kafka producer. The data lands on the topic partition leader and is replicated with Raft. Periodically, translation begins on the partition leaders, and upon seeing records, the translators do a schema lookup from the schema registry, though note that these schemas are cached, so this lookup actually isn't generally too extensive. The translator then RPCs out to the coordinator to get the table metadata, and the coordinator then creates the table or updates the schema if needed. And then the translators begin translating and uploading. Once done, the uploaders then the translators then send the files to the coordinator, who then appends the files to the table, writing any manifests or manifest lists to object storage with a merge append. And then the coordinator commits the append to the catalog and replicates a record of completion in the control topic. And at that point, the table is ready for querying with new data. And that is like the entire data path. Now, there's something to be said about exactly once delivery. Excuse me. In a data path with so many steps, there are plenty of opportunities for failure and duplicate data. So Redpanda in general supports the concepts of idempotent exactly once delivery and transactions within the confines of Apache Kafka's stack. And as I've mentioned throughout this presentation, all of our persistent metadata is replicated with Raft, which guarantees that up to a certain point in each replica's log, all replicas are identical. We use these guarantees to build a replicated state machine on translators and the coordinator and to track their own progress. So as data is handed off from translators to coordinators, the coordinator state machine can perform deterministic checks on the bounds of the translated Kafka data ranges to ensure that translation is only committed once per record. And in that sense, the coordinator is the source of truth for tracking new incoming translated files. Now, between the coordinator and the Iceberg catalog, in between the coordinator committing new files and the coordinator replicating state machine updates to the control topic, there is room for the catalog and coordinator state machine to be out of sync, but to avoid a possible repeated commit as part of the Iceberg update, we include some additional metadata to each snapshot indicating the control topic's current Iceberg committed record. So this allows subsequent appends by the coordinator to deduplicate files that were already committed. So please give it a try. If you scan this QR code or click the link here, it'll send you to Redpanda Labs Quick Start, which has a Docker Compose file with Redpanda, Smart SQL, a REST catalog, MinIO, and a sample schema for you to play around with, produce some data, and run some queries. And you can run it on the laptop. It's very easy to run. So check it out if you're interested. Now I'd like to talk about some of the challenges we faced in building out Iceberg topics. So the first problem, and it's a pretty obvious one if you're familiar or if you've been following the community for a while, is that Apache Iceberg has or had no support for C++. Now I acknowledge and maybe you want to publicize that there is a movement within the community to begin a C++ client. And as far as I can tell, it's still all very nascent, but very exciting to see. And since this wasn't around, it isn't really a full-fledged client yet, we built our own subset of a C++ client that includes just the functionality required for Iceberg topics. That's stuff like representing Iceberg data like schemas and values, representing serializing metadata like manifests and manifest lists and table metadata. We built out partitioning transforms for splitting data values like partition key. We have a transactions interface for updating table metadata. And we've implemented a few actions like merge append for data files, similar to the one in the Java and Python libraries, where an append will optionally merge manifests to reduce overall metadata size. Another action is to apply schema updates, and we're working on a couple others. And yeah, I mean, given the huge boom in development of REST catalogs, we've developed a REST catalog client as well. That we also have an object storage file system that is compatible with the Hadoop catalog. So as you may think, this C++ client in its own was a pretty big undertaking, but it was really critical to build solid foundations for us to enter the whole Iceberg space. Now, I did want to share a note about the C++ client code, that it's not quite a general purpose library, given it heavily relies on C*, our C++ framework, and various Redpanda-isms. And it's under a source available license, so you're able to look through the code, though do be mindful of the license. And as far as abstractions go, it's heavily inspired by the Java, Python, and Rust client implementations. So as an example, here is roughly the same interface from these upstream client implementations. And in each one, we have a transaction that can perform the action to append some files and then commit it to the catalog. And our implementation in C++ with C* looks very familiar with transactions class that appends some files and a method for committing a transaction to a catalog. So again, this code is source available, not quite open source. But if you're curious, you are welcome to read the code. Another major challenge is that of compute and storage. So Redpanda's thread per core architecture helps us saturate system resources, but not all resources saturate together. That makes sense. So the question is, how do we ensure, for example, that we don't overwhelm CPU while trying to saturate storage? And one solution we have is that C* has this concept of schedule and group priorities to allow us to reserve bandwidth for the things that matter for system stability, like Raft. And this helps enable relatively stable and predictable latencies. Another mechanism we're working on is automatic backpressure to Kafka topics to slow the rate of producers to ensure Redpanda's data translation can match the input rate of data. Another potential solution would be to separate compute from storage entirely, which is an idea that's fairly common these days. This would look very similar to a more traditional connector, though it would definitely come with its own unique set of challenges for Redpanda, and it's definitely something that we've had discussions about keeping in mind for the future. One final challenge that we faced with Iceberg topics is that we needed a full set of data primitives for data. Like the new requirement of deserializing and serializing different data formats is an interesting challenge for Redpanda in particular, because our C++ framework C* encourages writing asynchronous code without huge allocations, which are requirements that most data format libraries don't really follow out of the box. So for us, that meant having a deserializer for protobuf and avro and a serializer for Parquet. And as for what's coming up for Redpanda Iceberg topics in the next few weeks, I've mentioned a few of these already, but here's a more complete list. We're going to extend our schema evolution story to support more Iceberg compatible schema changes like removals and type promotion. We'll have support for a dead letter queue to stick any kind of invalid record data in. We're expanding support for data partitioning to allow users to specify their own custom partition spec to partition Iceberg tables how they want, rather than just by Redpanda's record timestamp. We're going to begin automatically running snapshot expiry to mitigate the huge size of metadata a streaming system like Redpanda can amass over the course of thousands of days. We'll have various custom improvements for performance, improved scheduling, automatic backup, as I said. We also have coming up backup and restore for the in-progress translation metadata. There are a few other features that we are thinking carefully about that aren't listed, like data ATPL or compaction, but these here are the ones that we're actively working on right now, and we're expecting to land in the next few weeks. And so overall, I'd say working on this feature and learning about the Iceberg ecosystem has been overall an extremely positive experience. Some of the things we loved are that the Iceberg spec, both the data spec and the REST spec, are very thorough. Like we did stumble upon some discrepancies among reading implementations through the client implementations, but ultimately they're pretty much all fixed. The upstream implementations are all very well thought out and make for solid foundations to learning the spec. I'd say the challenges that we see within the ecosystem as a relative newcomer to the scene are that not every implementation is equal, and by that I mean not every Iceberg integrator supports the same set of features. So like everyone kind of has their own subset of what's supported, which makes it kind of a challenge to support. And it makes cross-integration testing all the more important. So for instance, this kind of highlights my next point too, but recently the Hadoop catalog was deprecated, and this was something that happened as we were planning and building Iceberg topics. And we were lucky in that we could see it coming and plan for it, but it's something that not all organizations can adapt to so quickly. Not everyone wants to manage their own catalog or rely on another piece of hosted infra. And for a few third-party tools that still don't, it's pretty tough to support. But these changes ultimately are a good thing. But that doesn't make them any less challenging. Nevertheless, it does make it an exciting time to be a part of the ecosystem with such an active and burgeoning community. So that's my talk. My contact info is up here. Thank you all for joining. Beanie's in the back. Open the point.
We're running a bit late, but probably we'll still take a couple of questions before we move on to the last topic. Any questions? Yeah, for the last topic, we have Wes, who's going to talk about automated ERE constructions. While he sets it up, maybe we'll take a question, if that's okay, Andrew. Yeah, there's a question. So.
Oh, sorry.
Sorry, I have one question about the Redpanda. Yeah, thanks for your presentation. First of all, I want to ask the Iceberg topic can support streaming read from the Iceberg table?
Can we support streaming reads from an
Yeah.
Not directly from the table itself as Stream Native does, but as data is written to Kafka or to Redpanda through Kafka, you're able to stream that data through the Kafka API. It's still there.
Okay, so the data will be stored in Redpanda disk, and also another replica will be synced into the Iceberg table. Right. So there will be two pieces of data.
Yes.
One is in the Redpanda, another in the Iceberg table.
Yes.
Okay. And sounds like, okay, last question.
I actually just want to sort of add on to that. Like you can set the retention for your streaming data to be how much ever long you want. So if you say that I want my streaming data to only be available for 6 hours, then the 2 pieces of data is only for the 6 hours.
Okay.
Right? And then you have your table data that you can have for years even, but your streaming data is only there for 6 hours. So we provide that complete control over to the user to set how much time they want each kind of data to live.
Okay, got it. So last question is that looks like the Iceberg table just move the Iceberg sync connector from the connector ports into the Redpanda brokers.
Yeah.
But it brings one issue about the CPU.
Yeah.
We see that when we convert the raw data from the message from from the raw data into the column format, it will cost a lot of CPU.
That's right.
And for example, in the Redpanda or in the Kafka, the leader will be bind into the one broker. And if one broker holds thousands of topics, and each topic has a huge performance, huge throughput or small throughput, and they trigger the Iceberg offload at the same time. How will you handle the CPU pressure on your broker?
So in general, we support topic-aware balancing, so we'll spread Iceberg topic workloads across the cluster. But in general, like the general problem of having a lot of CPU kind of is reflected in what I mentioned of like this need for a solution for dealing with this. And right now that's scheduling groups. In the future, maybe back pressure to the Kafka system or separating compute and storage entirely. Did I answer your question?
Okay, you will do the auto rebalance or
Yeah, we do all balance.
The data, but also the leadership, so the workload of write be spread also on a topic basis. Multiple
Okay,
levels
okay.
of balancing together.
yeah, is there any plan to move the compact service out of the broker because it will introduce a high pressure? Maybe for the Redpanda, we don't have the memory issue, but we have the CPU issue.
Yeah, it's something that we're discussing, but we don't have concrete plans for it.
Okay, yeah, thank you.